All right, so this is going on page 110 when we're done. And this is, just like it says, it's a graphic organizer of your classic polar curve. So not every single polar curve that exists everywhere, but the classic basic ones that we start with. We're going to start with these, we're going to look through them, talk about their relationships, then we're going to be able to identify them and do some other little stuff with them. So this first column here is circles, like we looked at on Thursday, okay? So we also looked at, just r equals 5. That's a circle also that's centered at the pole, but that's not even on here because it's like super basic. So if I have r equals a cosine theta or r equals a sine theta, the diameter is a. So it's attached to the pole, your diameter is a. Remember, so on here it looks like what we have is an x and y axis. Remember that you do not have an x and y axis. All you have is the polar axis, which is really what we just did here, right here with A. But a lot of times those will be on there so that you can see it, visualize it, and kind of understand what's going on. But I talk about it as your pretend x-axis and your pretend y-axis, just to kind of help you, make sense of things. But if it's cosine, it's going to be on your pretend x-axis. If it's positive, it's on the positive side. If it's negative, it's on the negative side. If it's sine, it's going to be on your pretend y-axis, either positive or negative. So here, this specific graph on this specific grid is actually r equals 5 cosine theta, because our diameter is 5. This here is A. So this one is r equals negative 5 cosine theta. Then for these, this is r equals 5 sine theta, because this is A, this is A. So this is r equals negative 5 sine theta. Okay, so that's just like a quick review there from Thursday. So another family of polar curves that we have are what are called limacons. That's how you say this word, limacon. You have the C with the little thingy on it. Anybody in here in French and know what the little thingy is called? It's okay, I took 3 years of French and I have no idea what it's the little thingy on the C. It makes this sound. So it's a limacon. And this is the only one of the ones we are talking about right now that has more than one term. It's A plus or minus B cosine theta, A plus or minus B sine theta. All right? So we look at the relationship between A and B. If A over B is less than 1, that means that A is less than B. So if A is less than B, we get this limacon with the inner loop. Okay? And here's how these work. Because basically you have like 2 loops there, so you have 2 R values. Okay? So even though this is the diameter, this is an R value because it's the radius that's measured from the pole, right? So same thing here. We have this length here. This is A plus B. And then we have this length here. And this is A minus B. For this particular graph, this is R equals 1 plus 4, and then we're on the positive x-axis, so that's going to be cosine theta. Okay. Everybody okay with that? The big loop, this is A plus B. The little loop, that's A minus B. No, it's B minus A, not A minus B. Duh. If it was A minus B, that would be negative because of what that is. Let me fix that real quick. Fix that for me. This should be B minus A because B is bigger, and it's not going to be negative. Okay. Huh? R equals 1 plus 4 cosine theta. Okay. The next one is a cardioid because it kind of looks like a heart. And so this is when A over B equals 1, which means A equals B. And here we only have one R value, which is, again, it's kind of A plus B because A and B are the same. It's really 2 times A, but that is what A plus B is as well in this particular case. So for this specific graph, this is R equals, what is it? So since the R value, the diameter of it, it's not really the diameter, but this radius value of the graph here is 5, and A is half of that. This is going to be 5 halves. And then do you think this will be a sine or a cosine graph? Sine. Do you think it's positive or negative? Negative. So this is minus 5 halves sine theta. Right? It's on the negative pretend y-axis, so that's what makes it like that. Okay, we good so far? Then we have what's called the dimpled limison. The dimpled limison is like on its way to become a cardioid, like somebody kind of pushed that in a little bit, but it's not really there yet. So this is when, so it says A over B is between 1 and 2, so that means that B is less than A, which is less than 2B. You have from the pole out to here, that is A plus B. From the pole out to the other piece, this is A minus B. So you add them together to get one distance, you subtract them to get the other distance. Okay. So this particular graph would be R equals 3 minus, okay, and is it going to be sine or cosine? Cosine. Minus 2 cosine theta. Everybody understand how we understand if it's sine or cosine? Okay. Yep, it's which axis it's on there. All right, so then we have a convex limison. So this is the one on Delta Math where I said don't pick it. I know it kind of looks like a circle because this looks like a circle that somebody kind of pushed their finger into. This is almost like a flat tire, right? It's a circle, but it's kind of flat on the bottom there. And in this case, A over B is greater than or equal to 2, so that means that A is greater than or equal to 2B. In both of these cases, A is greater than B, but then you have to decide how much greater is it. Is it greater than or equal to 2B, or is it less than 2B? Okay. So again, the bigger part, this is A plus B. The smaller part is A minus B. And then this particular graph would be R equals 4. And is it going to be sine or cosine? Sine, positive or negative? Positive. Then it's plus sine theta. Because 4 plus 1 gives me this 5. 4 minus 1 gives me that 3 right there. Okay. On all 4 of those that are in the limison category, so limison is the only one that we're talking about right now that has an A and a B. In every single case, the biggest R value, okay, don't think of it as like, even though this is the diameter here, but this is an R value because it's an R value for your graph. The biggest R value we get from adding A plus B, even on that one, even though officially it says 2A, that is A plus B. And then the smaller one, you subtract the 2, whichever way gives you a positive number. Here, there's nothing to subtract. Okay, we good on that? Questions? Okay, so let's look at the roses. R equals A cosine n theta. So it looks very much like a circle equation. The difference is you have an n, you have a number in front of your theta of some sort. If n is odd, you have n petals. If n is even, you have 2 n petals. Okay. So here we have, this is 3 petals because it's R equals A cosine 3 theta. That's what gives me 3 petals, right? This right here is your A value, and that is 1, 2, 3, 4. So this is R equals 4 cosine 3 theta. And we want to look at the fact here that we have n equals 3. Now, The roses do not follow the same logic as the rest as far as if it's cosine, it's on the x-axis, it starts on the x-axis. If it's sine, it starts on the y-axis. The way roses work is that if it's cosine, we have something on the positive x-axis for sure. If it's sine, then it's rotated a little bit. And we're not going to get into how we even know how much it's rotated. I'm just going to kind of give you some of that because we're not going to get that deep into it. It's possible that if it's sine, we have something on the y-axis, but it doesn't work out exactly like that. Okay, and we'll talk about that a little bit more as we go. As you see here, we have r equals a sine 2 theta. So here n is 2. But how many petals do we have? 4, because it's even. And when it's even, you double it, right? So this is going to be r equals, and then this is my a value. And that is 4, right? So r equals 4 sine 2 theta. But notice, it's sine. I don't have anything on the y-axis, but it's not, if this was cosine instead of sine, it would be turned where this petal starts on the x-axis. If not, it's rotated, okay? All right, so then on the next one, here n is equal to 5. And so how many petals do we have? 5, because it's an odd number, right? So here, r equals 4 sine 5 theta. And here we are starting on the y-axis, but it's kind of a coincidence because here is where we would start if it was cosine, but it's rotated a little bit since it's not, and then we just go from there. Okay? But this is your a value. So sometimes it happens, sometimes it doesn't. It's not a given thing here. Then for this one, our r equals 4. And since it's even, we double that to get 8 petals. This is A, this is cosine, that's why we're starting on the x-axis there. So r equals 4 cosine 4 theta. What did I do wrong? Isn't it what? Oh, r, yes, thank you, n. Not r, sorry, thank you very much. Yes, n equals 4. R happens to equal 4 also, but that's not where I was going with that. So yes, thank you very much for fixing me. All right, are we all good so far? Okay. So then our second to last category is a lemniscate. It rhymes with limp biscuit. That's how you can remember it, lemniscate. Okay. So our lemniscates here is, we have, this is r squared. Now, it's possible to have an r squared equation that's not a lemniscate, but if it looks like it's, it kind of looks like maybe it would be a rose, right? If it's r squared and it kind of looks like it should be a rose, it's really a lemniscate. I say that because you could say that r squared equals 16. That's a circle with a radius 4, because we could take the square root of both sides. But if you have an r squared right now that has an equation, it's going to be a lemniscate. So since it's r squared equals a squared times the cosine of 2 theta, this is your a value. That a is 4. That's why this is r squared equals 16 cosine 2 theta. So it's kind of like a 2-petaled rose, although the little petals are a little fatter and it's not a rose. And then again, if it's cosine, we're on the x-axis. If it's sine, we're not. We're rotated 45 degrees. Okay. And I moved this thing. I probably can't move it again if I want to. See? Try to move this little box and I can't. Whatever. So this is r squared equals 16 times the sine of 2 theta. And that is my a value right there. Then the last one we're going to talk about is the spiral of Archimedes. We're not going to do anything with it, really. I just wanted you to, it's on here, so we'll see what it is. We should be able to identify it. So if we just have r equals a theta plus b, There's not like a cosine or a sine in there, but I do have r and theta. It makes it a spiral of Archimedes. Depending on if theta is greater than or less than 0, that's which way it spirals. Okay, that's it on that. Just look, identify what it is. We good? All right, so keep that handy. Let's go to the other piece of paper that you have, and let's try these. Going on page 111. You're going to use your graphic organizer to identify these equations. So we look at number 1. We have an r squared, and it's not just like r squared equals a number. So what is this thing? Lemniscate, right? Lemniscate. Then we have r equals 3 cosine 2 theta. So it's not a lemniscate because it's not r squared. I know it's not a limousin because it's not doesn't have 2 terms. But I have something in front of the theta. So what is it? A rose. How many petals? 4. This is a 4-petal rose. So if you're going to identify a rose, don't just say it's a rose. Make sure you say, how many petals it has. That goes along with it. All right, so number 3, I have 2 terms. As soon as I have 2 terms, I want to compare A and B. The first one's A, the second one's B, so A is greater than B. I know it has to be a limousin because it has 2 terms. The last 2, both A is bigger than B, and the last 2 is in both of the last 2. So I just have to decide, is A greater than or equal to 2B or not? Is A greater than or equal to 2B? No, so it's not a convex limousin, it is a dimpled limousin. All right, and then r equals 4 theta. I don't have any sine or cosine in that, so what is this? Spiral of Archimedes, yes. All right, I am going to give you 3 minutes to do the next ones. You can talk amongst yourselves about it. See if you can come up with what the last, or those 4 are right there. Oh, sorry. She was eating my sock. I will let the French know. I will call France on my conference period. Okie dokie. Your time's up. Let's look at these. All right, so on number 5, I have 2 terms, which tells me it puts it in the limacon category, and my A is greater than B. Is A greater than or equal to 2B? Yes, 2 is greater than or equal to 1 times 2, which is 2, which makes this a what? Convex limacon. Okay. So on number 6, A equals B. So what does that make it? Cardioid. All right. So 7, R equals 2 sine 7 theta. 7 petal rows, good, because it's odd. And then here A is less than B. Limacon with inner loop, good. All right, what questions do you have? Okay, so now we're going to sketch some. The word sketch has a different implication than the word graph, right? We are going to plot some points. We have to have some key points there. But if I really needed a beautiful graph, I would use graphing software. That's not the purpose of why we're graphing. We're graphing so that we can make sure we understand where the majority of the graph is, where does it intersect, and some key things about it to use in applications in the future. So let's look at number 9. I have 2 minus 2 sine theta. So here A equals B. So what type of curve is it? Cardioid. So your maximum R value, so if you look back at your chart for cardioid, that line that we drew, it says 2 times A. That, whatever number that is the largest R, that's the largest distance from the pole that you have, and that's just 2 times A, right? So in this case, that's 4. Okay. Cardioid is attached to the pole, so when we go to start graphing, I know I have a point right here. Then I know that I'm going to have a point that's 4 units away from the pole. I have to decide where that goes. This is sine and it's negative, so where's it going to go? Up, down, left, or right? Down. So I go to 4, and here, because it's like on your negative y-axis, right? So there's 2 other things. A couple of things we have to keep in mind with a cardioid. First of all is, yeah, it looks like a big fat heart, because it almost doesn't look like a heart. It's not going to look like this, right? That's a no on that. Sorry, it does not graph that way. It graphs this way. And so it actually goes above the axis a little bit, so I want to know where those intersection points are. So if I substitute it, so I know it will intersect my pretend x-axis, so if I substitute in my angle of 0, sine of 0 is 0, so I just have 2 minus 0, which is 2. Everything is symmetric, so if it's 2 over here, it's 2 over there. And then those points are going to be what help me to sketch my graph. Now, remember that it does not look like a heart that you would actually try and draw on purpose. So we don't want to exaggerate this up and over right here. It just kind of barely comes over like so, and barely comes over like so. And you have key points plotted. You do your best to make it look like you're trying to make a cardioid, and we're good enough. Okay. What questions do you have? We're good? All right. So let's look at the next one. R equals 3 cosine theta. What is this type of curve? It's just a circle. I heard it. It's just a circle. It's a simple one. Your maximum R value, 3, good, because that's your A value. So we know that these circles are attached to the pole, so I have a point right there. And then this is 3 cosine theta, so does my next point go left, right, up, or down? Right, because it's the positive x-axis type thing. Those are the only 2 points I need. This is exactly what we did on Thursday. And then we just do our best to make it look like we're attempting a circle, even though it may look like an egg or a football. It's all good. Okay. What questions we got? All right. So now let's look at 11. R equals 5 sine 3 theta. What is this? It's a rose. How many petals? 3. So this is a 3-petal rose. What is our maximum R value going to be? 5. Yes, it's 5. So we know that the roses are attached to the pole, so I can put a point there. Now this is sine, which means I do not start on the positive x-axis, and I don't automatically start on the positive y-axis. It's possible that one would be there, but we don't know that. It's rotated. I'm not going to really get into right now how you know how much it's rotated. We'll do mostly probably cosines with this or something that's a little bit easier, but I'm just going to tell you on this one. We're going to rotate to pi 6. Now, if you at least know that, then we can figure out the rest pretty easily. Because from pi 6, if I have 3 petals and there's 360 degrees, what's 360 divided by 3? 120. So I need to rotate 120 degrees from that, right? So this is like 30, right? Pi 6 is like 30? Yes? Okay. So that means I'd go to 150, which would be 30 before 180. So wouldn't I just be right there again? Yeah. And then I got to go another 120. This is 30, and then this is 90, so I end up right there. So I do end up on the y-axis, but it's the negative y-axis, and it's not because this says sine. Okay, the roses follow a different, they just dance to the beat of their own drum. And then we just make it look more like a daisy than a rose, but whatever. Everybody good so far? Alrighty, so number 12, we have 2 terms. So here A is less than B. If A is less than B, what do we end up with? Limousin with inner loop. Good. Limousin with inner loop. So this question only asks me for the maximum R value, but I actually have 2 R values that are important to me. To find the maximum R value, I add the 2, so 4 plus 2 is 6. And to find the other one I need, I subtract, so 4 minus 2, which is 2. So I'm just going to put it in parentheses. That way I already have my information. Then I'm going to graph. Okay? So Limousin with an inner loop, that is attached at the pole also, so I can go ahead and put my point there. Maybe. Put my point there. Then this is sine, and it's positive. So am I going to go left, right, up, or down? Up. So from here, I go up 6. From here, I also go up 2, because that's where I'm going to have my inner loop, and then this is where I'm going to have my outer loop, right? Then I need to check to see if it crosses the x-axis. So I'm going to substitute in 0. So sine of 0 is 0, so I'm really here at 2, and here at negative 2. Then I'm going to sketch. Okay. My inner loop, I got a loop right there. My outer loop, I come down a little bit and come around, come down a little bit and come around. Kind of looks like a seashell. It's bad. It's okay. All right. We good so far? Do you understand how to figure all this stuff out? It's really fairly simple as far as graphing is concerned. Okay. Let's look at the next one. What type of curve is this? Lemniscate. All right, lemniscate. What is your maximum R value? 4. Good, because this is a squared, so it's just 4. Lemniscate is attached to the pole. Since it's cosine, do we start left, right, up, or down? Left and right, yeah. So I have one here and one here. And then you just sketch it in like a bow tie, like infinity. Okay. We good? All right. What type of curve is the next one? It's a rose. How many petals? 4. Good. This is a 4-petal rose. The reason I know it's a rose and not a lemniscate is because it's not R squared, right? Okay, what's my maximum R value? 5. Roses are attached to the pole, so I can put a point there. This is cosine, so I am starting on the positive x-axis, so I can go out here to 4. I have 4 petals that I have to evenly distribute throughout the circle. What's 360 divided by 4? 90. So that makes this real easy, right? I just have one here, 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 and here. And then I can just sketch them in. Yeah. And they don't actually touch and they don't intersect, even though my picture is really bad. All right, everybody good so far? Any questions? Question? Yes. Shoot. Yes. Yes. Look, I'm going to just say, like my daddy always told me, do as I say, not as I do. Right? Okay. Thank you for fixing me once again. So yes, now this is my chance to make my picture look better than it did. So. Thank you. I'm sorry, I can't count. And I do want you using the correct numbers. I guess it's a little bit better, but not much better. Well, it's definitely better because it's on the right points now, but. All right, any questions? Layla, you with us? Okay, let's look at 15. I have 2 terms, so I have to look at A and B. A is greater than B. Is A greater than or equal to 2B? Is 5 greater than or equal to 2 times 1? Yes. So that makes it a what? Convex limicon. And since I have an A and a B, I actually have 2 R values that are important to me. Of course, the maximum one, so I add, even though it's negative, that doesn't matter. 5 and 1 gives me 6, and 5 minus 1 gives me 4. Convex limicon, not attached to the pole, so I'm not putting a point there. But from the pole, this is negative cosine, so my big part's on the left-hand side, right? So from the pole, I go out to 6. And then from the pole, I go the other way to 4. And then clearly, it's going to intersect the pi halves part right there, right? So I can get another point up here. What is the cosine of pi halves? 0. So really, I just here go to 5, which means I'd go to 5 over here. Then we're going to sketch it in, right? And remember, this is like the flattened circle. This would be the flattened side over here. You don't have to go to great lengths necessarily. I mean, hit the points that you have, and maybe it'll kind of look flattened. I mean, my circles never look like circles anyway, but it's really not supposed to be flat there. It's supposed to be more flat here, but whatever. I got the right points in there, and I connected them, so maybe I should try better. I'll try better. That's not necessarily any better, but you have your little organizer to let you know what it's really supposed to look like, okay? All right, what is number 16? It's a spiral. There's no sine or cosine in it, right? So this is the spiral of Archimedes. And that's all. I just wanted you to identify it. We're not going to worry about graphing them and stuff. That's not an important part of what we're doing. All right, so let's look at 17. What is 17? Lemniscate, good. All right, what's your maximum R value? 3, good. So it is attached to the pole. This is sine, so I'm not on the positive x-axis and I'm not on the positive y-axis because it kind of follows along with the roses. It's rotated, but the lemniscates will always be rotated 45 degrees when it's sine. So it's either flat or it's rotated 45 when it's for the ones that we're graphing anyway. And then it looks like a bow tie. Oof, that's real bad. Well, on the right points this time. Okay, I don't know if that's any better. But. All right, so what's 18? Or here, we have A is greater than B. Is A greater than or equal to 2B? No, which makes this a what? Dimpled limicon, good. All right, and then I add the 2 together and I get 5. I subtract the 2 and I get 1. Dimpled limicon is the other one that's not attached at the pole, but I start at the pole. This is positive sine, so from here I'm going to go up to 5 and make a point. Then I go the other way and make a point. Then I'm also going to substitute in my 0. So that means this would be at 3 and over here at 3. So your dimpled limicon is on its way from a convex limicon to becoming a cardioid, so it's just kind of dimpled, like it says. So it looks something like this. Okay, let me try again. Something like that. But actually connect those. And dotted lines are probably better and easier. My dotted lines don't really look like dotted lines on here, so I don't even try anymore. Oh gosh, come on now. That's even worse, but you get the idea. Okay. What questions do you have? Okay.